Imagine not having communication modes for transmission of data. Hello, my name is Vaishnavi and we are going to discuss about communication mode and different types of it. Let's get started. Communication mode. The way in which data is transmitted from one device to another device is known as communication mode. That is how the data is transmitted. This mode is also known as transmission mode. There are three types of communication mode, that is simplex, half duplex and full duplex. We are going to see all the three types in detail further. Here's the first one, simplex communication mode. The communication is unidirectional, that is in simplex data can transmit only in one direction. A device can only send data but cannot receive it, or it can only receive data but cannot send it. The performance of this mode is low as compared to other modes. Here are some pictures you can understand how the simplex communication works. Examples of simplex communication. The most common example is radio station, as it transmits the signals to listeners but never allow them to transmit back. Monitor. Monitor only displays output, it doesn't take any input. Keyboard. The keyboard which only accepts data from the user. Television. TV which accepts signal from broadcast but never transmits signal in return. The next one is half duplex communication mode. The communication is bidirectional in half duplex, that is, data can transmit in both directions but not simultaneously. The device can send and receive the data, but one at a time. That is, it either receives or transmits data. The performance of this mode is better than simplex mode but less than full duplex mode. Here are some pictures we can understand how the half duplex communication mode works. Examples of half duplex communication. The most common example is walkie-talkie. In walkie-talkie, one party speaks and other party listens. After a pause, the other party speaks and the first party listens. Both do not communicate simultaneously. If you do that in half duplex communication, the communication will be distorted. The next and the last one is full duplex communication mode. The communication is bidirectional. That is, in full duplex communication, data can transmit in both directions simultaneously. The device can send and receive the data simultaneously. That is what I said before. The performance of this mode is highest as compared to other modes. Here are some pictures of full duplex communication. That is how it works. Examples of full duplex communication mode. The most common and the known network is telephone network. When two people are communicating with each other by telephone line, both can talk and listen at same time. That is, we have experienced it like every day. Two computers connected via Ethernet cable, USB, etc. This is how all the communication modes works. Thank you.
Hello everyone, welcome to my video. In this video, we will discuss about following contents. First, definition of electronic communication. Second, block diagram of electronic communication system. Third, information about individual block. Definition: electronic communication is any form of communication that is broadcast, transmitted, stored, or viewed using electronic media such as computers, phones, email, and video. Here we can see the block diagram of electronic communication system. The first block is source information. It includes audio, video, computer and data, etc. Second block is transmitter block. Here the modulation of signal takes place. The next block is communication channel or medium, most important block of this diagram. The next block is receiver. Here demodulation of signal takes place. There is noise which can affect the communication channel. It also be found in the receiver block. The last block is destination. It is the place where the signal we are transmitting. Information source. The information source is the origin or the starting point of the information that needs to be communicated. It produces the message signal that needs to be transmitted to the intended destination. Transmitter. The transmitter is responsible for encoding the information from the information source into a form suitable for transmission through a communication channel. The transmitter performs operations like amplification, generation of high frequency carrier signal, and modulation. Communication channel. The channel is the physical medium which connects the transmitter with the physical medium. It includes copper wire, coaxial cable, fiber optic cable, waveguide, and free space or atmosphere, etc. Sometimes noise may affect the channel. Noise. Noise refers to any unwanted signal or interference that disturbs the clarity of the transmitted message. As it travels through the communication channel, noise can arise from various sources such as communication channel. Receiver. It receives modified version of the message signal from the channel and processes it to recreate the original non-electrical form of the message signal. In a receiver, it includes processing steps such as reception, amplification, mixing, demodulation, and a recreation of message signal. Destination. The destination is the final recipient of the transmitted message signal and processes it to comprehend the information present in it. It could be a person listening to an audio message, a computer receiving data, or any device that needs to be interpret the transmitted signal. Thank you everyone.
Hello everyone, my name is Shrutika Sandeep Suttar. Today I am presenting a concept of low level amplitude modulator circuit. Low level modulators generate AM with small signals and must be amplified before transmission. Diode modulator. Diode modulation consists of resistive mixing network, a diode rectifier, and an LC tuner circuit. The carrier is applied to one input resistor and the modulating signal to another input resistor. This resistive network causes the two signals to be linearly mixed, that is algebraically added. A diode passes half cycles when forward bias. The coil and capacitor repeatedly exchange energy, causing an oscillation or ringing at the resonant frequency. The diode is connected so that it is forward biased by the positive going half cycles of the input wave. During the negative portions of the wave, the diode is cut off and no signal passes. The current through the diode is series of positive going pulses whose amplitude varies in proportional to the amplitude of the modulating signal. These positive going pulses are applied to the parallel tuner circuit made up of L and C, which are resonant at the carrier frequency. Each time the diode conducts a pulse of current flows. Each time the diode conducts a pulse of current flows through the tuner circuit. The coil and capacitor repeatedly exchange energy, causing an oscillation or ringing at the resonant frequency. The oscillation of the tuner circuit creates one negative half cycle for every positive input pulse. High amplitude positive pulses because the tuner circuit to produce high amplitude negative pulses. Low amplitude positive pulses produce corresponding low amplitude negative pulses. The resulting waveform across the tuner circuit is an AM signal. The Q of the tuner circuit should be high enough to eliminate the harmonics and produce a clean sine wave, amplifying low level AM signals in low level modulator circuits such as those discussed above. The signals are generated at very low voltage and power amplitudes. The voltage is typically less than 1 volt and the power in milliwatts. In systems using low level modulation, the AM signal is applied to one or more linear amplifiers to increase its power level without distorting the signal.
Hello everyone, partition of charge carrier across the junction. Next one type is excess noise. This type of noise generated in electronic components such as avalanche diode and tunnel diode. And last one type is phase jitter. This type of noise affects accuracy and stability of digital clocks and data signals in digital communication. So today we learning complete the noise fundamental. I hope you can understand this type. Thank you.
Hello everyone, welcome. My name is Tanuja Chabuk. Today we will talk communication system, block diagram of communication system. First is information source, second is transmitter, third channel, fourth receiver, fifth destination, sixth noise. First one is information source. The information source converts message, speech, thoughts, text, news, etc. into the physical quantity. Second is transmitter. The transmitter is responsible for encoding the information from the information source into the from suitable transmission on through a communication channel. Third is channel. The channel is the physical medium which connects the transmitter with the receiver. The physical medium includes copper wire, coaxial cable, fiber optic cable, waveguide and free space or atmospheric etc. Fourth is noise. Noise can arise from various sources which as thermal noise, electrical interference or external signals. Fifth is receiver. It receives modified version of the message signal from the channel and processes it to recreate the original non-electrical from the message signal. Sixth is destination. It could be person listening to audio message, a computer receiving data, or any device that needed to interpret the transmitted signal.
Hello, I am Gagade Bhumi from SYETA class. I will explain a topic of analog communication. The topic is AM transmitters. Let's start it. In AM transmitters, there are mainly two parts, which are low level transmitter and high level transmitter. Let's start with first low level transmitters. Here is a block diagram in this. There are total 11 blocks. 3 at upper side, 4 at lower side and 4 at the middle with an antenna. The low level AM double sideband full carrier, in short DSBFC transmitter. Modulating signal source. It's a acoustic transducer such as microphone, a magnetic tape, a CD, etc. Preamplifier is typically a sensitive Class A linear voltage amplifier with a high input impedance which is used to raise the amplitude of the source signal to a usable level while producing minimum nonlinear distortion. Modulating signal driver is also a linear amplifier that simply amplifies the information signal to an adequate level to sufficiently drive the modulator. Buffer amplifier is a low gain, high input impedance linear amplifier. Its function is to isolate the oscillator from the high power amplifiers. The buffer provides a relatively constant load to the oscillator. Low level transmitters are used in wireless intercoms, remote control units, pager and short range walkie-talkie. Second is high level transmitters. Here is a block diagram. In this there are total 12 blocks. At the upper side there are 5 blocks and the lower side there are 4 blocks and the remaining 3 blocks are in the middle with an antenna. The high level AM double sideband full carrier, in short DSBFC transmitter. The power of the modulating signal must be considerably higher than is necessary. This is because the carrier is at full power at the point in the transmitter where modulation occurs. RF carrier oscillator. It does additional power amplification prior to the modulator stage. With high level transmitters, the modulator circuit has three primary functions. It provides the circuitry necessary for modulation occur. It is final power amplifier class C for efficiency and it is a frequency up converter. An up converter simply translates the low frequency signals to radio frequency signals that can be efficiently radiated from an antenna.
Hello, my name is Vaishnavi Sankhe. Now we learn amplitude modulation theory. Definition of amplitude modulation: as the amplitude of the carrier signal is made proportional to the instantaneous amplitude of the modulating voltage. In amplitude modulation, the amplitude of a carrier signal is varied by the modulating voltage, whose frequency is invariably lower than that of the carrier message signal. The message signal is a frequency sinusoidal waveform. Equation of message signal. Message signal usually expressed as m of t is equal to Vm sin omega mt is equal to Vm sin 2 pi fmt, where Vm is amplitude of the carrier signal, Fm is frequency of message signal, and t is time. Now carrier signal. Carrier signal is the message signal is a high frequency sinusoidal waveform. Equation of carrier signal. Carrier signal usually expressed as C of t is equal to Vc sin omega ct is equal to Vc sin 2 pi fct, where Vc is amplitude of the carrier signal, fc is frequency of a message signal, and t is time. Condition: in general, the amplitude of the modulating signal should be less than the amplitude of the carrier. Now we see equation 3. Equation 3 is represented as instantaneous value of the modulating signal algebraically added to the peak value of carrier. We can write the instantaneous value of the complete modulated wave by subtracting for the peak value of carrier the modulating signal, then modulated carrier, then amplitude modulated signal. Now we learn amplitude modulator with input and output signal. The given diagram is show the amplitude modulator with input and output signal is the instantaneous value of AM wave is carrier waveform, and the carrier waveform multiplied by the modulating signal waveform. The circuit used for producing AM is called a modulator. Its two input, the carrier and the modulating signal, and the resulting output are shown in figure. Now, modulation index. It is defined as the relationship between the amplitude of the modulating signal and the amplitude of the carrier signal is important. M is equal to Vm by Vc. Now, percentage of modulation. The given figure is show percentage of modulation. Vm is equal to Vmax minus Vmin divided by 2, where Vmax is peak value of the signal during modulation and Vmin is lowest value or throw of the modulated wave. Now the modulation index is M is equal to Vm by Vc is equal to Vmax minus Vmin divided by Vmax plus Vmin represent the modulation index. Thank you.
Hello friends, my name is Sanika Vittal Patil. So in this video, we are going to learn classification of electronic system into simplex, half duplex and full duplex. The simplex, half duplex and full duplex communication depends on the specific requirements of the application or system. Each type of communication has its advantages as use cases, and the appropriate selection ensures efficient data exchange based on the needs of communication scenario. So here we will see difference between simplex, half duplex and full duplex with their aspects. So the first aspect is communication type. Communication type of simplex is one-way communication. Communication type of half duplex is two-way communication but not simultaneously. Communication type of full duplex is two-way communication and simultaneously. So the second aspect is data flow. In simplex, data flow is unidirectional. In half duplex, data flow is bidirectional but not simultaneously. In full duplex, data flow is bidirectional and simultaneously. The third aspect is efficiency. Simplex communication has very low efficiency. Half duplex communication is less efficient than full duplex. Full duplex communication is highly effective. The fourth aspect is security. Simplex communication is less secure. Half duplex communication is more secure than simplex. Full duplex communication is highly secure. The fifth aspect is cost. Simplex communication has very low cost. Half duplex communication is less costly than full duplex. Full duplex communication is very costly. So here is the picture of simplex communication, that is TV broadcasting. This is the picture of half duplex communication, for example walkie talkie. Here is the picture of full duplex communication, that is telephone communication. Thank you.
Hello friends, today we learn about angle modulation. Angle modulation includes frequency modulation and phase modulation. Now we learn application of angle modulation. First one, commercial radio broadcasting. Then television, two-way mobile radio communication. Fourth one, cellular radio, microwave, and last one, satellite communication. Mathematical expression of angle modulation. A of t is equals to Vc cos omega ct plus theta t, where A of t represents angle modulation wave, Vc is equals to carrier amplitude, Wc is equals to 2 pi fc is equals to carrier radiant frequency, theta t is equals to instantaneous phase deviation and its unit is radian. In angle modulation, it is necessary that theta t must be a function of modulating signal represented as Vmt. Phase deviation mathematically represented as theta t is a function of Vmct. Now we study some terms and their definitions. Phase deviation. The amount of change in carrier phase is produced by the modulating signal. Now, frequency deviation. The amount of change in carrier frequency is produced by the modulating signal. Frequency modulation. By varying frequency of the constant amplitude carrier directly proportional to the amplitude of the modulating signal at a rate equal to the frequency of the modulating signal. Phase modulation. Varying phase of the constant amplitude carrier directly proportional to the amplitude of the modulating signal at a rate equal to the frequency of the modulating signal. Now we study mathematical representation of FM and PM. FM as frequency modulation and PM is phase modulation. Instantaneous phase deviation. Instantaneous change in the phase of the carrier at given instant of time and indicates how much phase of the carrier is changing with respect to its reference phase. Instantaneous phase deviation is equals to theta t. Instantaneous phase. It is the precise phase of the carrier at a given instant of time. Instantaneous phase is equals to omega ct plus theta t, where omega ct is equals to 2 pi fct carrier reference phase and its unit radian. Instantaneous frequency deviation. It is instantaneous change in the frequency and defined as the first time derivative of the instantaneous phase deviation. Deviation sensitivity. First one, phase modulation. Phase defined as an angle modulation in which the instantaneous phase deviation theta t is proportional to the amplitude of the modulating signal voltage and instantaneous frequency deviation is proportional to the slope or first time derivative of modulating signal. Second one, frequency modulation. It is defined as the angle modulation in which the instantaneous frequency deviation theta t is proportional to the amplitude of modulating signal voltage and instantaneous phase deviation is proportional to the integral of the modulating signal.
Welcome everyone, I am Tejaswini. We discuss the basic communication system and understand the fundamentals. So, what is communication? The communication system is a system which describes the information exchanged between two points. The process of transmission and reception of information is called as communication. The major elements of communication are the transmitter of information, the channel or medium of communication, and the receiver of information. What is the importance of communication system? In our daily life, communication help us to build relationship by allowing us to share our experiences, needs, and help us to connect to others. It's the essence of life information and share thoughts. We all need to communicate. Elements of basic communication system. First block is source. The objective of any communication system is to convey information from one point to other. In information includes some thoughts, news, talk, sign, etc. The information source converts this information into physical quantity. The physical manifestation of the information is termed as a message signal. Second block is transmitter. The objective of transmitter block is to connect the incoming message signal and modify it. In modulation, there are main two types, angle modulation and phase modulation. Third block is channel. The channel is the physical medium which connect the transmitter with that of receiver. The physical medium includes wires, coaxial wire, copper wire, and fiber optic wire in wireless, free space, or atmospheric air. Fourth block is receiver. The receiver block receives the incoming modified version of the message signal and process it to recreate the original form of the message signal. When communication flows from channel to receiver, there noise is created. Noise is an unwanted signal which interferes with the original message signal and corrupt the parameters of message signal. Last and final block of communication is destination. The destination is the final block in communication system which receives the message signal and process it to comprehend the information present in it. Types of signals. Analog signals. An analog signal is a voltage, current, or physical quantity that continuously and finitely varies in accordance with some time varying parameters. For example, radio wave, television wave, or sound wave are all examples of analog signal. Digital signal. A digital signal encodes data as a sequence of discrete value. A digital signal can only have one value from the finite set of possible values at any given time. For example, when we send a text message is converted into digital signal that is transmitted over the internet or cellular network. When we watch a video on a computer, the video is made up of series of digital signals that are converted into image and sound. Difference between analog and digital signal. In analog signal is continuous signal which represent physical measurement. In digital signal are discrete time signals generated by digital modulation. Analog signals are denoted by sine wave and digital signal are denoted by square wave. The examples of analog signals are human voice in air, analog in electronic device. The examples of digital signals are computers, CDs, DVDs, and all the digital electronic devices. Advantages and disadvantages of analog and digital signals. Advantages of analog signal. First is it is easier in processing. Second, it uses less bandwidth than digital sound. Advantages of digital signals. First, digital signals can convey information with less noise. Second, digital data can be easily compressed. Disadvantages of analog signals. First, analog tends to possess a lower quantity signal than digital. The second, the cable are sensitive to external influences. Disadvantage of digital signal. First, sampling may causes loss of information. Second, processor speed is limited. Signal processing. How signal processing works. Encoding. In computers, encoding is the process of putting a sequence of characters that includes letters, numbers, etc. into a specialized format for efficient transmission of storage. Importance of encoding. The primary purpose of encoding is to make data safely and adequately consumable by different users using various systems. The idea is to make the data readable and available to all possible end users. What is modulation? The process by which data and information is converted into electrical and digital signal for transferring that signals over a medium is called as modulation. Types of modulation. First one is amplitude modulation. Amplitude modulation is the process by which the wave signal is transmitted by modulating the amplitude of the signal. It is often called AM and it is commonly used in transmitting a piece of information through a radio carrier wave. Amplitude modulation is mostly used in the form of electronic communication. Second is frequency modulation. Frequency modulation is the encoding of information in a carrier wave by changing the instantaneous frequency of the wave. FM technology is widely used in the field of computing, telecommunications, and signal processing. Third one is phase modulation. Phase modulation is defined as the process of varying the phase of the carrier signal linearly with the instantaneous value of the message signal. So here basic communication system is completed. Thank you.
Hello friends, we are going to see noise figure. Noise figure is a measure of how much an electronic device or a system degrades the signal to noise ratio of signal passing through it. We can see here diagram. SI is equals to input signal power. NI is equals to input noise power. SO is equals to output noise power. NO is equals to output signal power. Formula: noise figure is equal to NF is equal to 10 into log 10 F, where F is equals to noise factor is equals to SNR in by SNR out. Application of noise figure. In this system, low noise amplifiers are essential components in receiver. LNAS aim to have low noise figures to amplify weak signals with minimal noise addition, allowing for better reception and detection of weak signals. Noise factor: it is ratio of input signal to noise power with respect to output signal to noise power when measured at same temperature. Formula: Ni or Si or So or No. Noise temperature. Noise temperature, it is used to quantify the equivalent noise power of fan system or electronic component. Formula: temperature is equals to F minus 1 2.
Hello everyone, today we are going to learn the noise factors and noise figure. So start with the definition of noise factor. It is a ratio of input signal power with the noise power at input or output of given system measured at same temperature. Formula: SI divided by NI divided by SO divided by NO. It is a unit less. And then definition of noise figure. It is a measure of how much an electronic device or system degrades the signal to noise bracket open SNE bracket close of a signal passing through it. Formula: NF is equals to 10 log to the base 10F. So let's move to the example on noise figures and noise factors. So the first example is a communication system operator with input signal power of 50 milliweber and input noise power of 35 milliweber. The same signal passed through communication channel which added output signal power of 60 milliweber and output noise power of 25 milliweber. Find noise factors and noise figures. Answer: given data, input signal power 50 milliweber, input noise power 35 milliweber, output signal power 60 milliweber, output noise power 25 milliweber. Noise factor
is equals to Si divided by Ni divided by So divided by No is equals to 50 milliweber divided by 35 milliweber divided by 60 milliweber divided by 25 milliweber is equals to 50 divided by 35 divided by 60 divided by 25 is equals to 10 divided by 7, 12 divided by 5 is equals to 10 divided by 7 into 5 divided by 12 is equals to 25 divided by 42 is equals to 0.5952. So we are moving towards the application of noise figure. First, it is used for high frequency applications such as RF and microwave communication. Second, in the system law, noise amplifiers are used to minimize external as well as external for internal noise.